All right, so here we go. So we want to solve for B. All right, so we want to solve this for a specified variable, solve it for V. Notice V is right here, so we want to get that V from under the radical. In order for us to do that, we're going to raise each side to the power of 3. So we're cubing each side, so this R cubed equal to 3V over 4 pi, because the cube root and the cube will cancel. Once again, your goal is to get V by itself. So now you multiply both sides by 4 pi. 4 pi cancel. So on the left, you now have 4 pi R cubed equal to 3V. Once again, your goal is to get V by itself. Now to finish it off, we divide both sides by 3. 3's cancel on the right, leaving me with V, and then there's 4 pi R cubed over 3. All right. All right, was that okay, Mr. Coley? Let me know.
I'm just writing it down. I'll go back and review the lecture.
Oh, okay. All right. All right. And of course, anybody else, is not a personal review from Mr. Coley. If anybody else have any questions, feel free, to mention something.
Can you scroll down real quick? I need to get that last part in the box.
Yes, sir. Let me write this since I was starting it. There you go.
Thanks.
Not a problem.
That's okay. Thank you.
All right, sounds good. Here, complex numbers. Remember we mentioned whenever you take the square root of a negative, you have to consider that, and really it's about the even root of a negative, but we're only dealing with square roots in this section. Whenever you have the square root of a negative, remember there's no way for you to actually take the square root of a negative value, so that creates an imaginary number. So wherein before, when we were just doing the square root of positive number, the square root of 4 was 2. Square root of negative 4 is going to be 2i. We say that that negative under the radical produces I, which represents your imaginary. So square root of negative 17 will be I squared 17, or if you want to write the square root of 17 in front of I, that's fine. Just make sure you don't extend this over the I. A lot of people make that mistake, so that's why I always like to use this way. That keeps us from making that mistake, but either or is fine. All right. Square root of negative 100 is 10i. Now, if you have the square root of something, of a number that cannot be taken the root of evenly, and we will handle it the same way we would in previous, even no matter the fact that we have a negative involved. So you will break it up into something that you can take the square root of, and the other piece that you can't. So you're talking about 9 times 2. Square root of negative 9 is going to be 3i, and then 2 would stay under your radical. You could take the square root of 9. You couldn't take square root of 2. 9 times 2 is still 18. Remember, we wouldn't break it up into 6 times 3 because you can't take the square root of 6 or 3. So that's why you would use 9 and 2. Also, another way of writing this is 3 square root of 2i. But once again, make sure you don't extend that radical over the I. So either way, it is okay. Is everybody okay with that concept before we add a little extra to it? So it's all about whenever you have the square root under your radical. So standard form of your, what we call this is complex number. You write your real part first, imaginary part second. That's always the standard form, real part first, imaginary part second. All right. So if you're going to add imaginary, let's see, did they do any multiplication? Yes, they did. Okay. So if you're going to add or subtract imaginary or complex numbers, you do it the same way you would combine the like terms. So if you have 5 plus 4i plus 3 minus 2i, 5 plus 3 is 8, 4 minus 2 is 2. So all you do is combine your like terms, 5 plus 3, 4i plus negative 2i. Same thing with subtraction. This minus sign needs to be distributed. Whether you write it out or not, make sure that minus sign touches each term that follows, and then combine your like terms. So you have 1 and 6, which would be 7, negative 8i, negative 3i, negative 11i. Any problems with that? So if you had to multiply, handle it the same way you would do your multiplication or your multiplying of your binomials, binomial distribution. 2 times 1, and then 2 times negative 4i. So this would be 2 minus 8i. 5i times 1, 5i times negative 4i. So that's 5i minus 20i squared. Make sure we're okay with the distribution.
Professor,
Yep.
I was reading in the book. So that I squared, is that a -1?
We're not finished.
Okay.
Yeah, we're not finished. But yes, you're absolutely correct. I was just writing down the next problem while you guys were writing. So, yep. So you want to simplify this as much as possible. So here, the first thing we recognize that we have like terms in the middle. And then like you just mentioned about that I squared. Let's write this. Excuse me. All right, so your most simplified expressions will not have I squared. So if you ever have I squared in your answer, you know that it can be simplified further. So negative 8i plus 5i is negative 3i. And so what happens with that I squared? And I didn't write this initially. I write it like this then. Stuff on erase. What's going on here? All right. I is the square root of negative 1. So it means I squared is the square root of negative 1 squared. And that square and that square root cancels. Now, you don't have to walk through this process. I'm just showing you. All you have to do really is remember that I squared is equal to negative 1. I'm just showing you why. All right, so it'll be negative 20 times negative 1. Negative 20 times negative 1 is positive 20. So now combine your like terms. Finish it off with 22 minus 3i. All right, make sure we're all right before we go to the next one. All right, so here we have negative 5 minus 3i times negative 5 minus 3i. So like I said, just like before, binomial distribution, whenever you square in a quantity, you write that quantity twice and then do your distribution or your multiplication.
Professor, I have a question.
Yep.
I don't know when to use a squared minus 2ab. Wait, a squared plus 2ab plus b squared.
Mm-hmm.
I get confused when I see a problem like this. When do I use that and when do I do this for?
Well, you can use that in this scenario, but it's not. Remember this though, you don't have to use it. It's not, and that's why I don't focus on it a lot.
Gotcha.
Because if you notice, I didn't mention it because it adds another element of something that people try, have to hold on to or try to remember or feel like they have to. When you really don't, all you have to do is just multiply your stuff out.
I got that from the book.
Yeah. Okay. Right. That's what I'm saying. You got it from the book. I didn't mention it because I didn't want to add. You guys got enough stuff that you're trying to hold on to.
Yeah,
I
so
didn't
don't
want to
even
add
worry
something
about
extra
it.
to it.
Just do it this way.
Hmm?
Don't even worry about that. Just do it this way.
Yeah. It's not necessary.
All right. I didn't know when to use what.
Right. And that's why I didn't talk about it because I didn't want to add. Y'all got enough. You know what I mean? So if you just multiply it out, you'll get the same answer. It's not necessary.
Right, thank you.
Yeah, not a problem. Not a problem. But this would be a scenario that you could use it on. Yeah. So negative 5 times negative 5 is positive 25. Negative 5 times negative 3i is positive 15i. Negative 3i times negative 5i is positive 15i. Then negative 3i times negative 3i is positive 9i squared. All right. Combine your like terms and get rid of that I squared. So that's a negative 9 now. So 25 minus 9 is 16. That'll be your answer. All right, questions. All right. If you have something like this, minus. And remember, we talked about being able to add and subtract terms that have radicals involved. Remember, you have to have the same index on your radicals, same radicand. That's the quantities under the radical. So notice you have -3 under the first term's radical, -12 under the second. So in its current state, you can't subtract them from each other. So you're gonna have to do something to modify the problem. So first of all, just always remember, if you have a negative under the radical, before you do any calculation, you want to get the I out, pull the I out front, get rid of the fact that you have a negative under your radical. But also here, I can break down this 12. So I can rewrite the first one as 6I squared root of 3. Next one, that's square root of -12. I'll break it up into -4 times 3. Square root of -4 is 2I, and I leave the 3 under the radical. So that'll be 5 times 2I square root of 3. 6I square root of 3 minus 10I square root of 3. And 6 minus 10 would be -4I square root of 3. Any questions on that? All right. Here, if I have the square root of -4 times the square root of -9, remember I just mentioned you always want to take the I first. What you don't want to do is multiply what's under the radical, because if I multiply what's under the radicals, that will be -4 times -9, which is positive 36. Positive 36 is 6. So that is the incorrect way of doing that. What you want to do, and I know we could take the even root of these, but let's say we didn't do it or didn't see that, I still have to take out the I. Now what happens when I multiply these together, I get I squared, square root of 36. And we already mentioned that I squared is -1. And square root of 36 is 6. So now we see that the answer is actually -6. So you always want to take out the I first. All right. One more like this. And then we should be able to be okay to do vertexes. I think that was under radical too. Yep. So just reiterating this type of process as well. Square root of -40 over the square root of 4. So again, you can take that I, bring it out front. And we can look at this as the square root of 40 over 4, since they both under the radical, the same radical, same index. So it'd be I square root of 10. 40 divided by 4 is 10. And I can't break up that 10 any further, so that would be the answer. Any questions?
Hey, Professor.
Yep.
Hey, hey, it's a quick connect math question.
Mhm.
On unit, I want to say the unit before the exam, it's not letting me take it.
What do you mean?
It's I guess it's the same thing that happened last time that I told you about the like that they had like a deadline on it.
Oh, okay. Well, I just like when did you try that?
I just pulled it up now to take it today, and it says that result 0%, and it doesn't let me like attempt it.
All right. So I just adjusted that because I know one of your classmates had pointed out that it was on that the 14th was the last date, and I just set all the dates to the 18th. So that should have been included in that.
Yeah,
But I
mine
do,
says I got a 0 for it.
you know what I'm saying? But I just adjusted it.
Mhm.
So does it say that right now?
Yeah, it says it right now.
Okay. I'll take a look at it and see why that didn't take. But that should have taken. Let me finish this lecture since
Mhm.
we're recording and everything. And then before I close out, I'll go back in there.
All right, thank you.
Yep, not a problem. All right, so let's go ahead and so anybody else as far as everything we've done so far before we get into vertexes? Everybody good?
Professor,
Yes, sir.
see, I would have messed up and squared that 4 prior to doing it.
You took the square root of it?
Yep, I would have made a mistake and did that.
Okay, that wouldn't have been a mistake. That would just been another way of doing it. So once again, you got to take the I out. So you would have been here. All right. So that means you want to also break up that 40 because if you took the square root of 4, that means you have 2 down bottom. So now how are you going to break up the 40? You break it up into 4 times 2, 4 times 10, excuse me, which means you're going to take the square root of 4 and leave the 10 under the radical. Square root of 4 is 2, so it'll be 2i square root of 10 over 2. 2 is cancel.
I would have made it more complicated.
Yeah, but it happens. But if you stay true to, what can and cannot happen mathematically, you still get the same answer. Yeah. All right. So let's look at vertexes real quick, or vertices. Let's see, what do they call the section? Why is this not? Thank you. Oh, vertex, yeah. All right, so when you talk about your vertex, it's either going to be the highest point or the lowest point of your parabola. So your quadratic equation always produces either a U or upside down U. And this would be your vertex. And they always call the coordinates of your vertex H and K. Let's see, which way I want to call this. call the standard form. I'll just call this, we'll just leave it like this. So now the form will be able to establish what our vertex or vertices are. Is a times x minus h squared plus k. So we can write our vertex in this form. This value right here is our first component of our vertex. This right here is the second component of our vertex. All right. Oh, I didn't write this. Let me write this too. Go back here. This is concave up. This is concave down. So if it's concave up, it's considered to be open upward. If it's concave down, it opens downward. So we're going to talk about that and establishing that in a second, but just go ahead and point that out. When it's opened upward, it's called concave up. When it opened down, it's called concave down. And I might as well write this. I'll write it down here. So our vertex, if you notice how it's set up, there's already a minus sign in the formula. So you're going to take, if I have -3 here, that means my vertex is just 3. You take the opposite sign. But here you just take the number that you have for k. So it's 3, 5. Because that minus sign is already in the formula. So let me go here. That means if I have f of x equal to 4. Excuse me.
Bless you.
Thank you, sir. Thank you. Sinus is acting up.
So what we do with that 2, Professor?
We'll get there, sir. Haven't gotten there yet. Trying to make sure we're okay with this vertex first. So this 7, if it's positive 7 right here, that means my vertex is going to be -7. So you take the opposite sign of whatever's in that parentheses.
Okay. And those are points?
That's your, yeah, that would be the ordered pair for your vertex. Just 1 point. Now, if A is positive, concave up. If A is negative, concave down. All right, I didn't mean to go past that. Sorry about that.
You ain't got that corona, do you?
No, sir. No,
You
sir. Say what?
Doing a lot of sniffing.
Yeah, man, my sinuses, man. I meant to take some last night because I was nose running and everything, man. Just every now and then, especially when the temperature changes.
I'm glad we virtual.
Yeah, because then I would go up and hug you, man, and cough all on you, man.
I ain't trying to get the virus. I noticed you during this recording, you'll hear a lot of sniffing.
But look, I don't have to listen to it.
Like he got that coronavirus.
All right. right. So here, so with that being said, since A is positive 2, that means that this first one will open upward or be concave up. And then the next one, A was -1. That means it will open downward or be concave down. All right, let's see. Oh, they ask you about the axis of symmetry. Okay. Also notice here, just looking at different things they're asking of you in a problem. If it opens upward, that means your vertex I'll just call it minimum. So your vertex is the lowest value if it opens upward. If it opens downward, then your vertex is a maximum. All right. So going back here, because it opens upward, that means this is a minimum. And then because it opens downward, this means this is a maximum. All right, so before we take a regular quadratic equation and put it in this form, questions on anything I have written?
I just got one, just to get it straight in my head, Professor.
Yes, sir.
A will always be the number that's in the parentheses, and B will always be 11, or the number that's the plus sign.
You said A and B. Now when you go, are you talking about right here?
Yes, where A, wait, hold on. In the parentheses, -H
Yes.
and K are the numbers we get our points from.
Right.
And when it says A equals 2,
Mm-hmm. And see what I could have written right here, because it wasn't about it being 2, it was about it being positive. So what I could have said was A equal to 2, A is positive. That means concave up. Same thing here. A was equal to -1. That means A is negative. And that means concave
down.
down, right? So it's about it being negative or positive, not necessarily about the number. You know, the number really doesn't matter. Is it negative or positive? That's what dictates your concavity. All right. So let's try this one from scratch. See all the things they ask you. Oh, axis of symmetry. All right, we'll do that in this next. Well, let's do this axis of symmetry if they ask for it. Let me do it like this now. Easiest way is just So that's how you do your axis of symmetry. Whatever h is, just x equal to h. And that will give you a vertical line right there at your the order pair of your vertex. So in other words, it's going to reflect about your vertex. So whatever h is, so here, my axis of symmetry is x equal to -7. Here, my axis of symmetry is x equal to 3. Question on the axis of symmetry. Once again, it's just the x component of your vertex. So you will write x equal to whatever that number is. All right, anything else new? Right. All right. So let's go ahead and do it. F of x equal to x squared 8x plus 13. All right, so first thing we recognize or look to do, so what's going to dictate what you do first is your leading coefficient. And we're talking about right here, what's sitting in front of x squared. If it's 1, you can just go ahead with your process. If not, you have to add an extra step. So here, a is equal to 1. So we're okay. And I'll show you in the next example what you would do extra. I'll just add one extra step if a was not equal to 1. All right. So first we're going to we're going to group the x terms together. So what we're going to do is do the completing the square on one side of the equation. We talked about completing the square. I think it was the last section that we covered new material. We do completing the square just on one side of the equation. All right, so we're going to have to take half of the b term and square it. Remember, the b term is a term that's sitting in front of x. We're going to take half of that b term and square it. So half of 8 is 4. 4 squared is 16. And now notice it says we're going to add and subtract it inside of the parentheses. So that's going to be x squared plus 8x plus 16 minus 16 plus 13. Plus and minus 16 is still 0, so we haven't changed the value of the equation. That's why you have to add and subtract it. Negative. All right, so next step is to remove the negative part from the parentheses, from the previous step, from out of the parentheses. So, and that's going to be more of a process if I had a number out front. Like I said, we'll talk about that in the next step. But that negative 16, we can take it out of the parentheses. All right. We can now factor the perfect square trinomial and simplify simplify what's outside of the parentheses. So don't forget, if you're having trouble factoring, and we talked about when completing the square, whatever half your b term is what should go there. So that's going to be x plus 4 squared. Then negative 16 plus 3 would be negative 3. All right, so now we have it in the form that we need. We see our vertex is going to be negative 4, negative 3. And we take the opposite sign here. A is equal to positive 1. So that means concave up. Axis of symmetry is going to be x equal to negative 4. All right. Questions on that before we do another one? And since it's concave up, that means that this is our minimum. Remember, if the concave up is like that, that means the vertex is the smallest value. right. Questions before we do another one? So let's do the same process. This time we have f of x equal to negative 2x squared plus 12x minus 16. All right, so a is equal to negative 2 this time. So we want to factor. Let's do this. Let's group together first. Like we said before, we're going to group together our x terms. A is equal to negative 2. So we're going to factor out negative 2 from each term. So we're not factoring out negative 2 from the 16, but from the 2x and the 12x. So negative 2 is on the outside. It'll be x squared minus 6x. And that minus 16 is still in the back. All right. So now we're going to go back to what we're doing. That was just the extra step that I talked about. If a is not equal to 1, you need to factor out that term that's sitting in front of x squared from those two terms, which is what we did here. So now we would take half this way. Take half of negative 6 and then square it. Half of negative 6 is negative 3. Negative 3 squared is 9. And we're going to add and subtract that inside of the parentheses. Now we want to get this negative 9 and bring it outside of the parentheses. But we have to remember that that negative 2 is supposed to hit each term that's in there. So we can't ignore the negative 2 that's sitting on the outside of that parentheses. So when I pull the negative 9 out, it needs to be multiplied by that negative 2. So in other words, it'll look something like this. So it's actually going to be a positive 18 sitting there. All right. Now we can factor. So I have negative 2. Remember, half of my b term, which is negative 3. So it's going to be x minus 3 squared. And then on the outside, 18 minus 16, which is a positive 2. So once it's in this form, then we are finished. As far as that part is concerned, we can extract the information. Our vertex is 3, 2. A is equal to negative 2. So that means it's concave down. I'll just write a CD. And then the axis of symmetry is going to be x equal to 3. And this is going to be a maximum because it's concave down. It's going to be the highest point of the vertex. Highest point of your parabola. Questions? Any questions?
I got a question, Professor.
Yes, sir.
Scroll back up. Right there. When you say -2 and you draw the red lines to each number,
Uh-huh.
you don't multiply that -2 times each one of those numbers?
Well, that's what actually is happening, but we're not doing it because we don't want, if I were to distribute the -2, it takes me back to this problem right here. And remember, we were going from this problem and we were trying to convert it to this. And that does not have my -2 distributed. You know what I mean? So it's all about how do you want to represent the equation?
The -2 is just multiplied to the outside number.
Right. You just leave it on the outside. Right. And like I said, and the only reason that this -9 is affected because I wanted to pull it out of the parentheses. And so if I'm gonna fully represent what happens in the equation correctly, when I take that -9 from the parentheses, that -2 has to be taken with it. It has to be multiplied to it.
Okay.
See, over here, this still represents that those three terms will be multiplied by that -2 at some point. Once I take that -9 out, if I don't include that -2, what you're telling people is that the -2 was never multiplied to the -9, which is not the case. So,
More steps. Got you.
yeah, unfortunately, sir. So now we're running out of time, but they may ask you for your y-intercept and x-intercept, and we've done that before. So don't forget your x-intercept is when y is equal to 0. Your y-intercept is when x is equal to 0. So all you'll do is substitute in 0 for y, solve it, then substitute 0 for x, and then solve it. And that's how you find your y-intercepts and your x-intercepts. Also, don't forget that y and f of x are the same. So, for example, when I look at this problem, let's go here. If I were to write this, f of x is equal to, I'm just writing anything right now, x minus 3 squared plus 2. This is the same thing as y equal to x minus 3 squared plus 2. So f of x and y are interchangeable. So once again, to find your x-intercept, you let y be equal to 0, plug 0 in there right there and solve for x. If I want to find my y-intercept, I let x be equal to 0 and then solve for y. All right. So before we close out, any questions on what you are here responsible for out of this section? All right. So try the stuff out. See if you get stuck. If you do, we got next class. Next week, as I mentioned before, we won't have any official classes, but if you need to meet with me, make sure you set that up. Shoot me an email, set that up, and we can do that. So I know I'm going to check that Map Connect thing before I completely close, but before I cut off the recording, is everybody all right? Excuse me.
I'm all good.
All right, so let me stop. Say it again.
It is what it is.